In this film are presented the practical results of many years' research by Mr. W.G. Whittlestone, one of the foremost workers in the world on machine milking. This work is still going on, but sufficient progress has been made to warrant certain definite recommendations to the dairy farmer. Nature has her own suction milkers. This calf is an example. He doesn't have to worry about technique, it just comes naturally to him. But he's all out for milking efficiency when it means more milk in his small stomach in less time. Although he doesn't know it, he's applying the same principles as the vacuum milking machine. Or rather, he's the model upon which milking machines are based. Man's adoption of hand milking was born of necessity. At best, it's an unnatural and somewhat clumsy expedient. The hand milker squeezes the teat and forces the milk out under pressure instead of by suction. All the same, milking by hand is not to be despised. The dairy industry was founded on this practice, and it gave man good service through the centuries until a better method was invented. Today, the business of milk extraction has become highly specialized. Your milking shed should be as streamlined as a well-run factory, and the milking machine should be treated like any other production tool and kept at the peak of efficiency. Every milker has to be a bit of an engineer. But before he can look after the maintenance of his machine, he needs to be sure he really understands the function of each part and knows where to look for danger spots. Here is a quarter-scale model of a milking machine for demonstration purposes. First, let's take a quick survey of the component parts. Unfortunately, a vacuum itself is invisible, so we can't see what happens to the air in the air system. But watch this strand of wool. It's light enough to get sucked right along the air line, past the releaser, until we lose sight of it in the vacuum tank. A similar strand of wool in the airdropper tube shows the pulsating movement of the vacuum system there. The vacuum pump is the center of the outfit. The rotating metal vanes draw air out of the machine, creating the partial vacuum. You can see them more clearly as the machine slows down. The speed at which the pump runs governs the amount of air it can draw out of the machine. Connected to the pump is the vacuum tank. Its job is to store vacuum, to trap any milk froth that might come through, and to collect cleansing liquids. Now let's retrace back along the path of the vacuum. The gauge, of course, tells the amount of vacuum. The level recommended by Ruakura is 14 to 15 inches. The relief valve, by admitting air, prevents the vacuum from rising too high. Watch the lick of flame as air rushes into the system. Now the pulsator. It produces the intermittent vacuum by connecting alternately with the outside air and with the vacuum system. For the instant the air is being admitted, the vacuum drops. When the air is closed off, it rises again. This is what produces the alternate squeeze and release at the cow end of the machine. Now we can see how it works on the udder. The teat cups consist of two components, the outer casing and the rubber inflations. When the vacuum is applied to the outside of the inflations, it releases them. When the vacuum is broken, they collapse. The alternate squeeze and release of the inflation is the action that massages the teat of the cow and stimulates the flow of milk. The milk then flows into the claw and thence to the dropper. To get a proper flow of milk from the cow, a small amount of air must be admitted into the claw. This speeds the milk on its way. The milk now goes up the dropper tube and into the sight glass. This is essential because it shows when the milk flow has stopped. The milk is now flowing along to the releaser. It consists of two parts. The main chamber is shut off from the spit chamber by a flap. The spit chamber connects with the vacuum system by means of a separate pulsator. By applying vacuum intermittently to the spit chamber, the opening and closing of the flap is controlled. Here is the whole machine at work. As you've seen, it's an organized collection of units, each with a particular job to do. A breakdown or loss of efficiency in any part will throw the rest out. That is why it's so important in the milking shed to keep the whole outfit in first-class running order by checking it over regularly. First, the vacuum pump. This is a precision instrument, and it depends for its efficiency on proper lubrication. The lubricators must be filled before every milking. Use rotary pump oil and none other. You can ruin a good pump if you use separator or crankcase oil. The task of the oil is to seal the moving parts of the pump. The bigger the plant, the faster the speed required to operate it. The milker can tell what vacuum his pump is producing by referring to the gauge. The vacuum here has fallen below the 15-inch ideal, so something must be wrong. A rev counter will give information about the speed of the pump. It appears to be lower than that recommended for the machine, so the pump obviously needs checking. There are various danger points. In this case, the belt is too slack and it's slipping. Tightening a belt can be an awkward and long-winded job in the older type of pump. Here's a much better idea. All you have to do is turn a knob. Next, the vacuum tank should be tested for leaks with a lighted match. This is a weak spot. And no wonder. It's caused by a perished flap, which looks worn and uneven beside the new one. A final test shows all is now well. Now we come to the unit which comprises the vacuum gauge and relief valve. We've already seen how the valve admits sufficient air to keep the vacuum steady. Too high a vacuum may damage the udder. This test shows how an over-high vacuum also bumps up the power consumption. Watch the meter on the left as the vacuum rises. This isn't only throwing good money away, it's overheating the pump into the bargain. Therefore, a reliable relief valve is essential. This is a weighted type designed by Whittlestone. It has proved itself under exhaustive tests at Ruakura. Listen to its performance. No air enters until the gauge reaches the correct level. Then the air starts coming in. This type of valve can be relied upon to prevent the vacuum rising too high. The streamlined model of the weighted type, enclosed in a plastic case, is now available to any farmer seeking a foolproof valve. The spring-loaded poppet valve is also satisfactory, provided it's kept in good order. This is the ball type. Watch its sorry showing on the test bench. Although the dial on the right shows that the vacuum is still low, listen to the air hissing through the valve. Unless the gauge is accurate and in good working order, it's difficult to check the performance of the other components. There's no reason to suspect this gauge. It goes up quite smoothly. But what about this one? Gauges are very temperamental things, and they don't always live up to their face. Here's a gauge that seems to be working correctly, but can it be trusted? The only gauge that can be relied upon to tell the truth is the mercury standard gauge. As the mercury rises well above the 15-inch level, it's acting as an automatic lie detector. An error of minus or plus 5 inches in the gauge may be quite unsuspected. Most of us have seen gauges like this, dirty and corroded. Unfortunately, it has been found that more than 50% of gauges in New Zealand are faulty. It's quite impossible to run your milking machine efficiently if your gauge is inaccurate and you don't know how the vacuum stands. A gauge is a precision instrument. The fine cog mechanism that drives the hands is delicately balanced and can easily go out of alignment. Careful cleaning and adjustment is needed to enable it to indicate the true vacuum. Therefore, it's most important at least every 6 months to have your gauge checked and reset by an expert. Next, we come to the pulsator. This is also very likely to go out of adjustment. We've already seen how it works, connecting vacuum and air alternately to the teat cup casing. Give it regular attention once a week to keep it up to the mark. The slide should be oiled. Wipe it first with a greasy rag to remove the dirt. A drop or two of oil once a week will ensure adequate lubrication, but too much oil may escape into the airline and ruin the rubber tubes. Make sure that each slide is set correctly. Normally, it should just clear the port. It's during the time it's clear that the squeeze occurs. For most efficient milking, the ratio would be 25 squeeze to 75 release. The action should be absolutely regular, and the rate should be about 40 pulsations a minute. The driving gear should also be oiled once a week, with a drop or two of oil on all bearings. A small amount of oil regularly is far better than a large amount now and then. Now the teat cups. Before each milking, inspect the air admission holes to make sure that they are quite clear. The milk doesn't get away properly if the hole is blocked, and it tends to form a solid column in the dropper. Some milk may even return up the teat and carry infection with it. Research at Wallaceville has shown that blocked air admission holes are associated with a higher incidence of mastitis. From the dropper tube into the sight glass. Here's the usual type of commercial glass. It gives good service, but because it shows milk splash even when very little milk is coming from the cow, it's difficult to decide exactly when milking has finished. A more efficient type, developed at Ruakura, empties completely once the flow of milk has fallen below ½ a pound a minute. At this rate, a cow has finished milking, and the cup should be removed immediately. The correct place for the sight glass is on the milk pipe. In this position, it can be seen from all parts of the shed. This milker has to walk halfway across the shed before he can see his sight glass. That's because it's placed low in the bale. Some people seem to think that there's an advantage in a low sight glass in that it takes the vacuum off the cow. Experiments have shown that this is quite wrong. A low-placed sight glass more often means that the cups are left on the cow long after milking has finished. The sort of thing that should never happen. It can cause serious damage to the delicate teat linings, besides discomfort to the cow. A good sight glass correctly placed is essential for efficient and safe milking. Now we come to the last group of components, the releaser and the releaser pulsator. The releaser pulsator has a different setting from the other pulsator. The milker can check the regular 50-50 pulse quite easily by feeling the tube with his fingers. You'll remember the construction of the releaser with two chambers and the flap operated by the pulsator. Trouble that occurs here is often due to leaks. These are detected in the usual way with a lighted match. We've now gone over the essential units of the milking machine. These should be simple in function and simple in design. We've already seen how easy it is to do maintenance jobs on the streamline pump. The older type looks primitive beside it. And what about this nest of belts and pulleys specially designed to catch the dirt? What's all this in aid of, cluttering up the plant like a Christmas tree? Many machines in New Zealand bristle with strange devices which are neither useful nor ornamental. There are plenty of slick salesmen going about the country selling gadgets that are more of a menace than a help. And plenty of farmers too with more money than sense. Encumbrances of this kind never make for milking efficiency. What's our calf back again for? Just to show you that he wants his meal in a hurry and knows how to get it. His method is simple, and the passage of milk from his mother's teat to his stomach is by the direct route. No gadgets there to impede its progress. His mother appreciates the simplicity of his method, and contented cows milk faster. So keep your plant down to the simplest essentials. Apart from anything else, there's enough to do to keep it in order without looking for trouble. In spite of plenty of care and attention to detail, accidents are likely to happen even in the best regulated sheds. Why the worried look? This farmer has noticed that the teats are swollen and hard. Swollen teats mean that the machine is operating at too high a vacuum. If the gauge is reading above 15 inches, then the valve should be adjusted until the vacuum comes down. If, on the other hand, it's reading 15 inches or under, the gauge is inaccurate and obviously needs checking. Here's trouble in a big way. Profits down the drain instead of into the vat. Quick action is called for. The releaser has flooded and milk has got into the air line. It has also got right through in behind the inflations. The trouble is probably due to leaky flaps. These should have been tested before milking started. It's a simple job, but it can cause havoc if it's neglected. Look at this. Why did they fall off? First check is the pump. Is the belt slipping? Is a bigger pulley needed on the motor? Does it need overhauling by an engineer? If the pump can't be blamed for the trouble, check for leaks after milking has finished. The relief valve may be sticking. In that case, it will need taking to pieces, oiling and cleaning. The inflations may be old and slack. There's no need to let them get into this condition. They should be replaced every 6 weeks. Make sure, though, that the new ones are of the right size and correctly adjusted. The final check is the vacuum gauge. This should be tested and adjusted as required. Regular checking will avoid much trouble. These are the main points to remember. Before each milking, fill the lubricators. Check all air admission holes. Make sure that the relief valve is working properly and that the gauge reads 14 to 15 inches. Every week, oil the pulsator slides and check them for seating. Oil the pulsator drive and inspect all bearings and drives. Check the releaser, vacuum tank and joints for leaks. Check for tightness of the inflations. Every fortnight, dismantle the cups and soak the inflations and all tubes in boiling caustic soda solution for a couple of hours. This will double their effective working life. And finally, at 6 monthly intervals, the whole plant needs overhauling by an expert. This is a job for the competent serviceman. Scattered about New Zealand, a few cooperative dairy companies provide a milking machine service for their suppliers. The Kataya Dairy Company was the pioneer, and others have followed the lead. This system has proved both efficient and economical. The sale of milking machines in those areas has decreased as a result of the competent servicing. But whichever way you get your servicing done, make sure that it's done regularly and by an expert, so that the machine is always kept in first-class running order, ready to do its best right throughout the season. Now here is Dr. McMeekin of Ruakura to sum up the 5 main principles.
It may seem a little unnecessary for scientists to spend their time studying milking machines and attempting to teach dairymen how to use them. But as every farmer knows, a sound milking procedure is just as essential to high production from a dairy herd as good quality and well-fed cattle. Let's have a look at the Waikato herd averages for 1947-48. The average of all cows for the district was 259 pounds of butterfat. The lowest herd yielded only 175 pounds. The highest herd was one from Ruakura, where 126 cows averaged 354 pounds of fat. I'm quite certain that the high performance of this herd was in part due to careful machine milking. This herd is not outstanding in dairy quality. The cattle are typical, well-bred grade jerseys. Ample, good quality pasture, hay and silage have been the only feeds. But it is a herd where the 5 points of good machine milking have been carefully observed. These points are worth remembering. 1. Secure the cooperation of the cow by treating her kindly at all times. Treat her as a pal, and she will repay by giving all her milk. 2. Stimulate her to let down her milk 1 minute before the cups go on. A regular procedure in washing the udder and teats and in drawing the foremilk to detect possible mastitis is essential to rapid and complete milking. 3. Strip with a machine. Hand stripping is unnecessary. Pulling down on the cups will remove all the stripping. Even the more difficult cows can be trained to respond to a machine stripping routine. 4. Remove the cups immediately milk flow ceases. A good sight glass is essential to time the milking end point accurately. 5. Operate and maintain the machine as shown in this film. All these simple rules are the result of careful and painstaking research. They should be remembered by every dairyman seeking maximum efficiency.
Finally, don't forget these essentials for an efficient milking machine. Simplicity in design is the keynote. Avoid unnecessary gadgets and complicated mechanisms. Make sure you have a pump of sufficient capacity for the size of the plant. a weighted relief valve that can't go wrong, a vacuum gauge that doesn't lie, inflations that are kept tight by regular maintenance and replacement, and a sight glass that's easily and accurately read. Maintain such a machine in efficient working order by the same regular care and attention as must be devoted to the cow herself, and the full benefit of cooperation between man, cow, and machine will be obtained.